So it'll be really useful for you here to at least once in your mathematical career see a proof of a quantity like this. So we want to prove the identity that the cosine of u minus v is the same thing as the cosine of u times the cosine of v added to the sine of u times the sine of v. How was that working out? Well, we're going to actually do a couple of things right here. And let me explain these two drawings right here that you're looking at. What you're seeing in the first circle right here is a unit circle. Both of these are unit circles. So we're just taking the same unit circle. And what we're going to do is we're going to use a little bit of our wrapping function knowledge here in order to identify a little bit of a similarity between these two circles. First of all, if it's a unit circle, that means that the hypotenuse of each of these triangles is always 1, that if we would form them. But even more than that, when we talk about any coordinate point along the xy axis right here, any x and y coordinate point that is on the unit circle is a coordinate point such that x squared added to y squared is equal to 1. And the reason that we point that is that xy coordinate then becomes the sine and cosine. So reviewing a little bit, that means that over here, at this point corresponding to angle A in standard position, the x coordinate is cosine of A, and the y coordinate is the sine of A. Meanwhile, over here for angle B, the x coordinate here is the cosine of B, and the y coordinate is the sine of B. So why is that important? Well, what we'll see right here is that what we were really interested in is the distance between these 2 points. What would actually be the distance between these two? So that's the reason why I wrote out my distance formula right here. We can calculate that distance. Right? We say that, all right, if we have x2, the distance between any two xy coordinate points in the plane is equal to the square root of the difference of the x values squared plus the difference in the y values squared. That's our Pythagorean theorem at work. Well, what is x2 and x1 right here? Well, let's go with making this x2 and y2 here at this coordinate point. And let's go ahead and make this x1 and y1 at this coordinate point. So what should we say? Well, our distance here in this first case will be equal to the square root of cosine of A minus cosine of B, quantity squared, right? That's x2 minus x1, x2, x1, right? Plus the difference in our y values. Well, in this case, our y values, y2 is the sine of A, and y1 is the sine of B. So that quantity is squared. All right. So bear that in mind. That is actually the distance between these 2 points. Now, here's another thing that I did. I said, well, all right, let's take that same angle that we got from angle A to angle B and take the difference between them, right? That is the distance, that is the angle A minus B. So I put that angle A minus B over here in standard position. That's what we're looking at. Just imagine this piece right here being rotated around so that it's in standard position. What does that mean for us? Well, remember we're on a unit circle. So the x coordinate right here is 1, and the y coordinate here is 0 when we're right at this point along the x-axis. This other point over here, well, this is x here. That's our cosine of A minus B, and our y coordinate is sine of A minus B. So let's go with the same sort of arrangement right here. Let's call this point x2 and y2, and let's call this original point x1 and y1. So we can again use our distance formula to find the distance between those two. What is our distance formula? Well, in this case, we're going to take the difference in the x value. So x2 is the cosine of the quantity a minus b, and x1 is 1. So we take that difference and square it, and we're going to add that to sine a minus b, which is y2, and we're going to subtract from that y1, which is 0 squared. Okay, so what about these two? Well, from geometry, it turns out that if we take the angle a minus b and take the distance between those two, and we take the distance between 1, 0 and this point a minus b, those two distances right here, distance 1 and distance 2, must equal each other. Which is kind of helpful for us because here's distance 1 and here's distance 2. In fact, we have an equation where these two things are set equal to each other. Well, all right. If the square root of the cosine of a minus b minus cosine b squared plus sine a minus sine b squared is equal to the square root of cosine of a minus b minus 1 squared plus sine a minus b minus 0 squared, then in fact these two quantities under the radicals must equal each other. So we actually have this equation. Cosine of A minus cosine of B squared plus sine of A minus sine of B, again squared, must equal cosine of the angle A minus B minus 1 squared, and since we're subtracting 0, I'm going to drop that minus 0 part, plus square of the sine of the angle A minus B. All right, well that's useful for us. Why? Well, because now we can do a little bit of subtraction to help us out. And we can do a little bit of subtraction right here. Get that straightened out. We can actually do a little bit of algebra right here. You remember your formulas. One formula said that if we take the difference x minus y and square that quantity by the FOIL method, we would get x squared minus 2xy plus y squared. Well, that's what we have right here. We've got cosine of A minus cosine of B taking the place of x and y. So let's go ahead and multiply that out. So if we square cosine A minus cosine B, we get cosine squared A minus 2 cosine A cosine B, right, x and y, plus cosine squared B. Let's do the same thing to sine. Okay, so we're going to get sine squared A minus 2 sine A sine B, right, that's our x times 2 times x times y bit here, plus sine squared B. We have one more place that we have to do this with, and that's with cosine of A minus B minus 1. So I'll write that over here on the left. So when we factor this out, when we multiply this out, cosine squared A minus B is what we get, minus 2 cosine of A minus B, right? It'd be 2 times 1 times cosine A minus B, plus 1, plus the square of sine of A minus B from that very last term. Looks like we've got this huge long string of terms. We want to see if we can reduce this down just a little bit. So let's do that right now. We might note a couple of things. First of all, there are some like terms here. Let's point them out. Cosine squared A is added to sine squared A. Pythagorean theorem time, right? You remember that. Cosine squared A plus sine squared A, that's equal to 1. We also have cosine squared B being added to sine squared B right here. So on the left-hand side, we can actually shorten this down a little bit, and we're going to get the following. On the left, cosine squared A plus sine squared A, as we said, that's equal to 1. And then cosine squared b plus sine squared b, that's equal to 1. And so that left-hand side reduces to 2 minus 2 cosine A cosine B minus 2 sine A sine B. Now we look at this right-hand side over here and check this out. We have cosine squared A minus B plus sine squared A minus B. And you know what that means. Adding these two quantities together will give us 1. Right? So when we add these two guys together, put them together, we just get equal 1. Right? And so if we rewrite our right-hand side, we have 2 minus 2 cosine of A minus B. All right, a little bit of algebra time. Once again, we could subtract 2 from both sides, and that term is just going to drop out altogether. So we're left with negative 2 cosine A cosine B minus 2 sine A sine B equal to negative 2 cosine A minus B. And on the left-hand side, we might notice that we have a common factor of negative 2 between each of these two terms. So if we factor that out, we get negative 2 times cosine A cosine B plus sine A sine B equals negative 2 times cosine of A minus B. And you know what that means. Divide both sides by negative 2 to get rid of the common factor, and lo and behold, we get our formula cosine of A plus times cosine of B plus sine of A times sine of B equals the cosine of A minus B. That's exactly what we were looking for. That's the kind of thing that makes Professor Peoples happy. It's true. More to come in the next video.